Let's take a look at this first problem here. And for this problem, we want to draw the reflected light rays off of this mirror here using a protractor. And so what I want to keep in mind before I begin is when I use my protractor, what I really want to do is line up this point right here where the light ray hits the mirror with this little notch on my protractor. So I'm going to go ahead, I'm going to drag my protractor up and place it right there. And sometimes, obviously my protractor is a little covered up here. What I can always do is I can redraw that light ray coming in. It's kind of coming in like that. Something along those lines, line it up even more. But just so I can see kind of what I'm working with here. And so I see that this is coming in. If I look at the angle, measured from here, it's about a 48-degree angle. Technically I should measure from the normal, but with reflected rays, which would be 42 degrees, but with reflected rays it doesn't actually matter. So I'm just going to leave that there like that. And I'm going to draw the light ray going out then. It's going to go out along the same angle. So I see that the 48 mark would be right about here. So I go ahead and draw my ray going out, and it looks something like that. Now we move on to the second one. This one I could go ahead and line my protractor up if I wanted to, once again, but what I'm going to find is it goes directly in to the mirror, so that means it's going to reflect directly back out. So this reflected ray would just look something like that, going straight back from the mirror. Alright, so we have another problem here where we are going to go ahead and draw the reflected rays coming off of a snowman. But before I do that, I'm actually going to go ahead and extend each one of these light rays that's coming in and going off of the mirror, and that's just going to make it easier for me to line up my protractor. So I'll go ahead and do that, and then I can move my protractor in place for that first ray there, and so we're going to line it up with that notch there, and I see that this is coming off at an angle of about 82 degrees, and so my reflected ray will come off like that at that same angle of 82 degrees. Do be aware that the top set of numbers goes from 0 to 180, going the one direction, the bottom goes from 0 to 180 in the other direction, so this 82 here is actually the same as like 98 as well, just something to keep an eye out for. Now that I have that first one, I'm going to go ahead and slide my protractor down to the next ray, and I see that that's coming in here at an angle of about 75 degrees, so I'm going to draw my other ray off at the same angle of 75 degrees like that. And then moving on to my third and final ray, I move my protractor down. I see that this one is coming in, and again I'm measuring this angle here. Looks like at about 72 degrees. So I'm going to draw my next one going off, also at an angle of 72 degrees like that. Alright, so for this next one we have a Snell's law problem. So we're going to go ahead and set up Snell's law equation, which is n1 sine of theta 1 equals n2 sine of theta 2. We see here there are two angles are already measured from that normal, so there's no need to change those angles over. We are told that the first n is 1.2 in that initial substance, so we have 1.2 sine of 70. It's going to be equal to 2.5, which is n2 times sine of theta 2. So we go ahead and we can calculate what that left side of the equation becomes, and it's 1.127 is equal to 2.5 times sine of theta 2. We divide both sides by 2.5, and we end up getting that this left side is going to be 0.451, and that's equal to sine of theta 2. Here we're going to take that inverse sine of both sides, which remember we do second plus sine on our calculator in order to get to that point. And when we do that, we get that theta 2 is going to be equal to the inverse sine of 0.451, which gives us an angle here of 26.8 degrees. All right, for this next problem, we have another Snell's law, another refraction here. And so we're going to go ahead and set this up once again with n1 sine theta 1 equals n2 sine of theta 2. The one thing we want to be careful about is, as you can see here, our normal line is this line right here. We always do want to measure those angles from the normal. So these two angles given are actually not the ones we want. We want to use 90 minus those angles to get the angle from the normal. So this angle is really going to be 65 degrees, and this angle up here will really be 51 degrees. So we can go ahead and say 1.33, that's our index of refraction, that first substance, times sine of 65 equals n2, which is what we're ultimately looking for, times the sine of 51. So that left side of the equation becomes 1.21, and that's equal to n2 times, and you can either leave it as sine of 51 or find the value of that, which is 0.777. You'll divide both sides by that value, either, again, 0.777 or sine of 51, and we'll find that n2 in this case is going to be 1.55.